This video explain the need to use a relative measures of dispersion. Relative measures of dispersion is used when comparison of dispersion for sets of data when their means are not equal. Comparison of dispersion for sets of data when the scale used is different.
The measurement is coefficient of variation, CV, is equal to S divided by X bar, multiply by 100. The smaller the value of the coefficient, the more consistent is the set of data. Example.
The average age of the accountants at Three Rivers Corp is 26 years with a standard deviation of 6 years. The average salary of the accountants is $31,000 with a standard deviation of $4,000. Compare the variations of each and income.
Given X bar of age is equal to 26 years. The standard deviation of age is equal to 6 years. The CV of age is equal to 6 over 26 multiplied by 100 equals to 23.1%.
X bar of salary is equal to $31,000. Standard deviation of salary is equal to $4,000. Coefficient variations of salary is equal to 4,000 over 31,000 multiplied by 100 equals to 12.9%.
Coefficient variation of salary is smaller than the coefficient variation of age. Hence, the distribution of salary is more consistent compares to their distributions of age. The degree of skewness of a frequency curve can be measured using Pearson's measure of skewness. 1. Pearson's measure of skewness is mean minus mode divided by the standard deviation.
2. Pearson's measure of skewness is mean minus median divided by the standard deviation multiplied by 3.
The range of values for the measure of skewness is between -3 and +3.
The lowest value is -3, indicating perfectly skewed to the left, or perfectly negative skewed. When Pearson's measure of skewness is around -1.5, we can interpret it as moderately negative skewed, or moderately skewed to the left. When Pearson's measure of skewness is near to 0 on the negative side, we can interpret it as slightly negative skewed, or slightly skewed to the left.
The maximum value is +3, indicating the frequency curve is perfectly skewed to the right, or perfectly positive skewed. When the value is around +1.5, the frequency is moderately skewed to the right, or moderately positive skewed. When the value is close to 0 on the positive side, the frequency curve is slightly skewed to the right, or slightly positive skewed.
Pearson measure of skewness measurement is equal to 0 when the shape of the frequency curve is normal.
Example. The increases in cents in cigarette taxes for 17 states union a 6-month period are as follows. Determine the skewness of the data set.
You can verify that X bar is equal to 38.3529. Standard deviation is equal to 18.231, and median is equal to 40. Hence, Pearson's measure of skewness is 3 multiply by 38.3529 minus 40 divided by 18.231, which is equal to -0.271. The distribution is slightly skewed to the left. Thank you for watching.